Ahi ahi Marie. Good afternoon, everyone, and welcome to today's CPD webinar brought to you by Rinnai, New Zealand. I'm Alice Wu, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about hot water ring main systems. Now, while we're waiting for everyone to arrive into the room, let's test our chat function by typing our answers to this question. Your dream holiday destination. So again, where would you like to go for a holiday? If cost is not an issue, please type your answers in the chat. So for those of you that just joined us, we're testing the chat function by typing our answers for this question, your dream holiday destination. I've seen Japan on the answers quite a bit. Singapore, oh, we're everywhere. We're around the world. So it's great. I'm surprised that I haven't seen that many tropical countries, considering we're in the middle of winter. So, any more answers coming in? Great. I see Spain on the answers quite a bit, and another one for Japan. Okay, well, thank you everyone for all your answers, and good to know that chat is working. Let's make a start. Welcome to today's CPD webinar brought to you by Rinnai, New Zealand. I'm Alice, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about hot water ring main systems. This is a topic that we have been asked very often. The webinar aims to assist architects and specifiers to gain a better understanding on ring main systems and how they work with different types of water heaters. Today's format will be 40 minutes of presentation, followed by Q&A with 10 NZRAB CPD points. For smooth running of the presentation, we kindly ask you to submit your questions in the Q&A section, and we'll answer them during Q&A time. Again, please type your questions in the Q&A section, and we'll answer them during Q&A time. If you've joined us via Teams web format and may not have all the functionalities or simply too shy to ask questions publicly, don't worry, we'll have our contact details at the end for you to send questions through privately. Now let's start with a 1-minute introduction about Rinnai. Rinnai has been in New Zealand for over 45 years and is located in Auckland. With over 1 million appliances installed into Kiwi homes and businesses, Rinnai New Zealand has established a proud reputation for quality and reliability. Rinnai's mission is creating a sustainable, healthy and comfortable way of living. We provide a range of products and services that covers climate control and water heating solutions, and we're the expert in total home living. For water heating, Rinnai has gas infinities, hot water cylinders, hot water heat pump and commercial solutions. For climate control, we have heat pumps, gas central heating, gas fireplaces, electric fireplaces and Wilmington wood burners. Now, without further ado, it is my pleasure to introduce our speaker for today, Dr. Grant Burke. Grant has almost 40 years of experience in water heating and graduated from the University of Auckland with PhD in mechanical engineering. He has lectured in building services at AUT University and assists Rinnai with water heating specification, installation design and fault finding from residential through to large commercial buildings. Over to you, Grant.
Thanks, Alice. Thanks everyone for joining us today. So we'll just have a quick look at what we're going to cover in the webinar. So we'll quickly look at what a ring main is, why we want one. We'll have a brief look at the building code compliance implications. We'll have a look at a hot water ring main and then a different variation which is called a warm water ring main and which one you should be looking at for your project. We're going to look at how to minimize the running costs on ring mains. And then we're going to have a look at different types of water heaters with ring mains. So we'll look at electric storage, gas storage, gas continuous flow, and a heat pump with a ring main. So if we jump right into it, what is a ring main? So here we have a reasonably large house with bathrooms at each end of the house and the kitchen in the middle. And what we've got here is not a ring main. So we've got the hot water heater in a cupboard in the corridor. So when I get up in the morning from bedroom 4 and go to the toilet and wash my hands, I have to empty the cold water out of the pipe on the way to that basin before I get any hot water. In reality, because only washing my hands briefly, I'm likely not to get any hot water out of the tap. So now I move and I decide to have a shower. I'll get hot water to my shower a little bit quicker because I'd already put hot water into this section of the pipe. And then I go and have a shave after my shower and I'll get hot water reasonably quickly. So now somebody at the other end of the house stumbles out of bed and turns on their shower. They've got to wait a very long time in order to get hot water because there's a lot of cold water to empty out of the pipe. And then at my laundry, I'll have hot water available reasonably quickly. And again, at my kitchen sink, provided someone in bedroom 1 en suite's been using the hot water won't be too far away. If the kitchen sink was the first tap I'd turned on, it'd take quite a while to get the hot water out of it. As we learnt in the last webinar, the council are interested in the distance from the water heater to the kitchen sink, and Building Code Clause H1 calls out standard 4305, which has some minimum pipe lengths required between the water heater and the kitchen sink. There's no minimum pipe length between the water heater and other fixtures. And in fact, my view is that these maximum pipe lengths are still quite long, and that if you went to 7 meters of 20mm pipe between the water heater and the kitchen sink, it would take quite a while for the water to get there. So that's what we've got in that house if we don't have a ring main. We could, of course, put multiple water heaters in other places. So let's have a look at that same house with a ring main set up. So one of the advantages of a ring main is we can put our water heater anywhere. We can put it outside here. We could put it in the corner of the garage. We could put it outside at the other end of the house. Once we've got the ring main, we're not limited to where the water heater goes. And obviously many houses, terraced houses, other architecturally designed houses, finding a spot for the water heater is difficult. So a ring main allows us to put it anywhere. So we have a water pipe running around the house. We have a pump on a return line coming from the furthest outlet. So what we do is we turn the pump on, the pump starts to turn, and it will start pushing water around the ring main. So water comes out of the water heater and it starts to flow around that ring main in the house. Then once we get to the furthest outlet, we can have a little skinny pipe that comes back to the pump, because we're not needing lots of flow through that pipe. All we're needing is enough water to trickle through it, so it keeps the water circulating for us. So the water comes back through the pump and into the tank where it gets, or into the water heater, whichever type you've chosen, so that it gets reheated. So now when I walk up to my kitchen sink, my hot water is available really quickly at my kitchen sink. I'm not having to wait a long time in order to get water there, and the same at any other outlet. The closer we run the ring main to each fixture, the quicker the water will be available, but water will be available a lot quicker than with the other system. The other benefit is that this distance from the ring main to my fixture is now my H1 distance for compliance. So I'm not running into any arguments with the council about how far my water heater is from my kitchen sink. So that's our basic ring main. There's lots of other variations on this theme. If we could put the water heater near to the kitchen sink, and let's say we only had one bathroom on this end of the house, we could run a direct pipe to the kitchen sink, and we could run just a little ring main off to the bathroom. And the same would be the reverse. If we didn't have this bathroom down in the bottom corner of the house, we could put the tank here, run a direct hot water feed to this ensuite, and a little ring main to the kitchen sink and back. So there's lots of variations on that same theme, but that's basically how a ring main works. So if we have a look now at what's good about them and what's not so good about them. So obviously the main benefit is that I turn a tap on and I get hot water straight away at that outlet. Most hotels will have this type of system, and obviously you'll be on the 15th floor of the hotel and you turn the tap on and you get hot water pretty quickly. As I said before, the water heater can be anywhere. We're not now having to think about getting the water heater close to the kitchen sink or any other outlet. We can stick it out the back somewhere. We can even stick it in the outbuilding and trench the pipes underground into the main building if we had to. So certainly at my house this morning, when I went to have a shave, I ran a whole lot of cold and then lukewarm water down the drain while I waited for hot water to arrive. So when I turn on the tap on the ring main, there's hot water there straight away, so I'm not running water down the drain. So some of the limitations of a ring main can be more expensive to install. Obviously, there's more pipe and there's a pump, and there's some other fittings that we'll talk about in a minute. It requires more planning, and certainly on projects that we've worked on with architects, there's conversations required between the architect, the customer, the client, and the plumber and the builder in a new building to make sure that it all goes smoothly. And that's really what we want to get across today is the information you need to pass on to make sure that this process goes smoothly for everybody. Some domestic plumbers may not have done them before. We are very happy to provide them with guidance. We provide them with detailed drawings. We're happy to talk to them on the phone. In theory, they should know how to do it. In practice, they're reasonably rare. So not every plumber you come across will be completely confident in just exactly what to do, but we're very happy to help them. And this is a moderately big one. There's a fixed running cost from the heat lost from the ring main. We had hotels in Queenstown ring us up during COVID saying, what's going on? We've got this reasonably sizable gas bill and there's 2 people staying in our hotel. Why is that? And what they were realizing and seeing for the first time was the fixed cost of keeping that ring main hot all the time, even though there were only a small number of guests in the hotel. And so what we'll talk about a bit later is what we can do to minimize those heat losses and therefore minimize the cost of running that ring main in a client's property. So let's look now at some building code compliance things. So this is really about all water heaters. We have a couple of building code performance requirements, 12.3.6. So sanitary fixtures for personal hygiene must be delivered at a temperature that avoids scalding. So we can't have super hot water come out our taps. So how do we deal with that normally? For bars, basins, showers, and bidets, we have to limit the water to less than 55 degrees, and that rule will be changing at the end of the year to be less than 50 degrees. Certainly a bidet, I don't want 65-degree water in my bidet, thank you very much. That wouldn't be very pleasant. And the way we do that is using a mixing valve, normally on an electric storage tank, and normally we reduce the water heater to the whole house to less than 55 degrees. A little bit different for a ring main, as we'll see in a minute. So the other one that I'm sure all of you are familiar with is that the hot water system shouldn't grow Legionella bacteria. So the way we deal with that is where we store water, we store it at greater than 60 degrees. When we have a ring main, we can have the water go around the ring main at greater than 60, and that will keep it disinfected for Legionella. Or we'll see in a minute, there's another way of doing a ring main where we put the water out at less than 60. Because of the risk of bacteria growing in that cooler water, we kill the bacteria by taking the return via a UV sterilizer. So this is an either or. We either do it at greater than 60, or if we do it at less than 60, we sterilize it with a UV sterilizer. We don't normally do both. So this gives rise, these building code compliance clauses give rise to 2 different ring main concepts that we can use. So the first one is what we call a hot water ring main. So we store the water at greater than 60 if we are storing water. We circulate the water at greater than 60, and 65 is a common sort of a temperature to circulate that hot water at around the house. And then at each point that we take a hot water takeoff to a sanitary fixture for personal hygiene, we use a mixing valve at that point to reduce it to less than 55. The other type is a warm water ring main. Again, if we're storing water, we store it at greater than 60. We circulate the water at less than 55. Because we're circulating the water at less than 55, we don't need mixing valves. Obviously, from the end of the year, consents issued from the end of the year, the water will need to be circulated at less than 50. And then we have the UV sterilizer installed on the ring main return in order to guard against any Legionella bacteria. So let's have a look at those two different types of ring main in a little bit more detail. We'll have a look at the hot water ring main first. So this picture might be starting to make you go a little bit cross-eyed. I've just zoomed in on the sort of top half of that house we were looking at before. And what I've done now is drawn in the cold water pipe that runs around the house, as well as the hot water pipe that runs around the house. So we've got the cold water pipe. It's coming into our water heater, and it's then branching off to provide cold water around the house. And the hot water ring main is going around the house as it was before. And I've put the return in a dotted line just because there were too many lines on the page. So let's say I stagger out of bed and I jump in the shower in the ensuite and I turn the shower mixer on. The ring main is nice and hot. I'd take water off the ring main to a mixing valve. The mixing valve mixes cold water with that hot. I get water less than 55 come out. My shower mixer mixes some more cold in, and I take the water at the shower. So I've got 65-degree water coming off the ring main. I've got 55-degree water coming out of the mixing valve, and then I've got 40-degree water coming out of the shower. So at each bathroom, I need to have a mixing valve installed. If there were two bathrooms back to back, there's no reason why I can't use one mixing valve to supply two bathrooms or more, for example. But basically, I need a mixing valve at each offtake. So in this design, I would have had another mixing valve down the other end of the house for the other bathroom and powder room. Now I'm down at the kitchen and I turn the kitchen tap on. I don't need a mixing valve at my kitchen tap because it's not for personal hygiene, so I'm allowed hotter water there, so I can take straight 65-degree water out of my kitchen sink if I want. Now, if I've got a client that doesn't want 65-degree water at their kitchen sink, they want the water a bit colder, there's no reason why I can't put a mixing valve under the kitchen sink and reduce that water temperature a little bit if they don't want really hot water coming out of the kitchen sink. If there's vulnerable people in the house or they're worried about their children, they can also put a mixing valve on these other fixtures. So that's basically how the hot water ring main works. I put sort of neat hot water around the house, and then at each offtake point, I have a mixing valve to reduce that temperature down. So let's have a little bit of a look at these mixing valves, and this is where we get lots of discussions with the architect about where we're going to put them, and we have discussions with the plumbers about putting them somewhere sensible. So we'll just go into that in a little more detail now. So if I look at a schematic of a couple of mixing valves, say going to a couple of bathrooms, within that it's a little more complicated than what was shown in the previous slide. So I've got a mixing valve that mixes cold with hot and makes less than 55-degree warm. Either side of the mixing valve, I've got non-return valves. So there's two non-return valves, one either side. What can happen over the life of a building is that debris in the pipes will stick in the non-return valves and they won't close. They will stay open a little bit. And what can happen, not in a new installation, but over a period of time, if this non-return had some stuff under its seat and it wasn't closing fully, when I turn the hot water tap on coming off the next mixing valve, it can draw cold water across the mixing valve and it can draw cold water into that hot water ring main of the building, and vice versa. If this one's sticking open, it can draw hot water into the cold side. And I have spent numbers of hours of my life crawling around buildings trying to find the mixing valves, so that the non-returns can be removed and replaced, so we don't have lukewarm water in both our hot water supply and our cold water supply. Doesn't happen instantly, but it happens as buildings get older. So it's really important that we have, in this type of design, that we have good access to get at and maintain these mixing valves and the non-returns either side. And so here's a little group set that someone supplies that's got a little hatch with a cover. If you can put these in an accessible place under your house, of course you don't need a little hatch cover. If you can put them in your attic, where the plumber can get at them for maintenance in the future, not a problem. But often you'll need to put them in the walls of your house. They might have to be a ceiling behind the door in the powder room. That previous house we were looking at, I don't think anyone would mind if there was one of these in the back of the walk-in wardrobe, supplying the ensuite next door. So we need to find places to put these, and we need to ensure that the plumber quotes for and makes sure that they're going to put these non-returns somewhere that they can be got at in the future. If they can't be, it creates problems. And obviously, discussions with customers required into where they're happy to see these things located. Probably this hatch is about 350, 400 millimeters square, to give you an idea of the sort of size that you're looking for. So when you're going with a hot water ring main, it's really important that you have a discussion with your client and a discussion and a specification for the plumber, so everybody's really clear that these valves are going to be able to be got at in the future. So that's really what we need to know about a hot water ring main. The other option is what we call a warm water ring main. So again, going a little bit cross-eyed here now, I should stress that none of the pictures you've seen in this presentation are plumbing schematics. I've simplified them a bit. If you have a particular project, we can send you a schematic of exactly how to do it, but we've simplified these for the purpose of the presentation. So what we're doing in a warm water ring main is we have one big mixing valve, doing the whole house. And so we don't need mixing valves at each offtake. We don't need to find places for multiple mixing valves around the house. So we have one big mixing valve, we have hot water coming off the tank, and then we circulate the water around the dwelling, and we measure the water temperature at the closest sanitary fixture for personal hygiene, and we adjust this mixing valve till we've got 55 degrees at this closest fixture, which means the other fixtures will have slightly lower temperatures than that. So we're then compliant. So again, if I stagger out of bed in the morning and I turn the shower mixer on in the ensuite, I now take 55 degree water off the ring main, and I have 40 degree water coming to the shower. So I've still got 65 degree water coming from or stored in my hot water plant. My mixing valve reduces to 55 in the ring main. I have 55 degree water coming out the branch and 40 degree water coming out of the shower. Now, one of the the good things about this is I don't need to find places for those mixing valves. I can put them all near the hot water plant. One of the downsides of it, the ring main return needs to come back through a UV sterilizer. UV sterilizer is a long, shiny looking tube that has a big long bulb in it. One of the disadvantages of these is the bulb needs to be replaced annually. So there is some maintenance on these. There's a little controller attached to it. It has a little countdown on it, and it sounds an alarm after a year, and you need to put another bulb into the UV sterilizer. So if I come down now to my kitchen and I turn my kitchen tap on, I've only got 55 degrees water, less whatever heat loss I've had in that ring main come out of my kitchen tap. So some people may be perfectly happy with 55 degree waters at their kitchen tap. Others may think that 55 is not hot enough, in which case a bit more thought's required. It may be that a small underbench cylinder is required in the scullery or in the kitchen in order to boost that 55 back up to 60 degrees or 65 that the client wants at the kitchen sink. But 55 is fine for lots of people. These systems are really common in big buildings because we could end up with hundreds of mixing valves scattered around the place. We also had an architect where we worked on a system, and everywhere that we could find where we could potentially put a mixing valve that the customer was, the client was happy with, there was a firewall and we couldn't cut into the jib. So we ended up with this system. It was in a terraced house development, so that we could put the hot water plant tucked away and the customer would just have to arrange to replace this bulb every year. It's not electrical work, it's low voltage, it's not plumbing work, there's no plumbing work involved, so the client can potentially replace it themselves if they want, or they can call a plumber to have a bit of a check of things and replace the bulb and the sterilizer at the same time. The bulb is not one that you can go and pick up from Bunnings on a Saturday morning, and they are specific to the make of UV sterilizer that you've been sold. So normally if I'm writing a specification, I ask the plumber to buy 5 extra bulbs for the UV sterilizer and hand them to the client. They're pretty fragile, but the client can tuck them away somewhere safely, and then there's no issue with accessing bulbs when the alarm starts going off on this UV sterilizer. So that is the two basic systems, a hot system and a warm system. So the question is, which one should I be using? So as with everything in engineering, there's always compromises. So for a small system, you're going to have a small number of mixing valves. Usually a hot water ring main is more cost effective. So most of your domestic houses, a hot water ring main is what will be appropriate. As the systems get larger, a warm water ring main becomes cheaper. Fully hot water to the furthest outlet. Obviously, a hot water ring main is better for that. We can provide it in a warm water ring main, but we may need to boost the hot water up in a small cylinder at the kitchen or scullery outlets. So same again, very, very hot water to the kitchen sink is, as I just mentioned. Sorry, just going back to this fully hot water to the furthest outlet, I didn't explain this quite right. If you're 100 meters away, obviously you're going to lose some heat across that distance. So with a hot water ring main, you've got a bit more heat to lose before somebody's moaning about the water being not hot enough. This fully hot water to the furthest outlet can be addressed with lots of insulation, and we'll talk about that in a minute. Lack of places to put accessible mixing valves, as I spoke about that one where there were lots of firewalls. Obviously, a warm water ring main comes into its own in that case. Cross connection between hot and cold. Again, a warm water ring main can't happen, or it's much less likely to happen, or it's much easier to diagnose if it does. So where we have large numbers of mixing valves, or would have large numbers of mixing valves, a warm water ring main is sometimes the option, because we're not having to crawl around hundreds of rooms in hotels and maintain mixing valves. And then minimal maintenance, so we're not having a UV sterilizer. Obviously, a hot water ring main doesn't have the sterilizer. We don't have to worry about it every year. So that's the basic questions to be asking yourself when you're considering for a project, which type of ring main I should be using. Most of your domestic houses, a hot water ring main will be appropriate, but not always. As I mentioned before, the hot water in the ring main, if we keep it hot 24/7, there's some heat loss out of that. That becomes a fixed running cost. If you use zero hot water in your property, you've still got to pay for that heat loss. And we get comments about this, so we try and include in our specifications matters to mitigate this running cost. So the first thing we need to do is insulate the ring main. So there's lots of ring mains that are really poorly insulated, but there's no option but to insulate it really well. Having insulated the ring main, the next thing we do is insulate the ring main some more. We can't overstate the importance of good insulation on a ring main. So we suggest 30mm thickness, so often two 15mm layers thick of tubular insulation. So that means a 25mm bore pipe that would be common in a reasonably large house on a ring main will still fit in your 4x2 or 88mm deep stud. So if we have a look at what good insulation looks like, this is, to a building services engineer, this picture is quite exciting because we're a bit sad, clearly. So this is obviously a commercial installation. So we've got the cold water coming down the stainless steel pipe and through the blue valve. And then we've got this beautiful insulation job that you very rarely see. So you can see here all the valves have been insulated and the handles are just sticking out of them. Up here at the top, this big cylinder is the UV sterilizer. You can see the UV bulb through the little greeny blue light there, through the port there. They've insulated the UV sterilizer. So obviously this standard of insulation is excellent. It came as no surprise to me to learn that this wasn't done by a plumber. So the plumbing procedure for doing this work is all the plumbing pipes are connected. The plumber then pressurizes the pipes and makes sure there's no leaks. At that point, the insulation is something that's sort of the last thing you do before you leave the job. This particular insulation job on this building that's done beautifully was subcontracted out to the air conditioning engineers. Now, air conditioning engineers, if they don't insulate the pipes perfectly because they're running chilled water, water will condense on the pipes and then drip onto the ceilings of the house and cause damage. So the HVAC guys do beautiful insulation work, and we need to try and encourage our plumbers to do equally beautiful insulation work on ring mains, because it will reduce the cost of running that ring main significantly. So if you're in a cold place, if you're in Queenstown, try and run the ring main within the insulated building envelope, and certainly insulation over it in ceiling cavities. Obviously, we're going to lose a lot more heat out of even a reasonably well insulated pipe if it's sitting in an uninsulated attic space in Queenstown at -10 degrees. This is one we recommend, is to turn off the ring main pump with a timer in off-peak times. So you can go, the little ring main pumps just run off 230-volt power. They're often plugged into a wall socket. Go down to Bunnings and Mitre 10 and buy a $15 clockwork timer and turn your ring main pump off from 10 at night till 5 in the morning. Turning the ring main off doesn't turn your water heater off. So if you did get up at 2 o'clock in the morning and want to shower, if you're having an early flight and you turn the hot tap on, you'd still get hot water. You just have to wait a while for it. The other suggestion is consider a ring main pump with a temperature sensor. So here's a picture of one. So there's a little temperature sensor with a zip tie, and that's clipped to the pipe. The insulation's put over it. Then when the ring main pump determines that the ring main's hot, it will shut down the ring main pump, wait till the pipe cools down a little bit, and then turn on again. So the average temperature in our ring main is less, so we will lose less heat from it. If we just have a look at that in an application, provided I've got room, what I've done now is I've shifted the pump with the temperature sensor down to past the furthest outlet offtake. So I'm on the ring main return pipe, but rather than being up near the water heater, I've shifted it down to the furthest point. These things are tiny little pumps and they run really quietly. So I wouldn't want it under my pillow, but it can be quite near to bedrooms without causing nuisance from noise. So if I turn that pump on and my water starts to flow around the ring main, when it gets back to my pump, the pump decides that it's hot and the pump will stop. Now, it doesn't work quite as neatly as this. I'll have some lukewarm water going up this ring main return pipe. But if I've got this ring main return pipe in general less hot, my running cost of my system will be lower. We've had customers, particularly on LPG installations in large houses, that have complained to us about the cost of the LPG. And we've had them fit just simple timers to their pumps, and they've reduced their hot water or their LPG cost by between a third and a half. So it's quite significant. In California, very energy conscious place, of course, a ring main with a pump running constantly is no longer compliant with their building code. They will do things like put motion sensors in bathrooms, and the pump will start up when it sees occupants up and about, and also perhaps learning algorithms for pumps so that the pump will turn on in general when there's more people needing hot water. So let's look now at how we might organise a ring main with different types of water heaters, and there's subtle differences between how we do it with each water heater type. So what you're going to see is not a plumbing schematic, so don't sort of take a photo of it and go home and hook it up like that. We've got detailed hydraulic drawings. We've got hundreds of drawings in our library, and if you contact the architectural team, we'd be very happy to send you a specification that you can give to your plumber to have a ring main installed in a particular site. Each of the pictures we're going to show have just got one water heater there. Obviously, in larger houses, we often have multiple water heaters. The same applies. We can send you schematics with multiple water heaters with ring mains. So starting with the simplest, electric storage water heater. Really straightforward. We just take the hot out the top. We run the ring main around the house. We take our hot offtake points to our various fixtures, and the pump just pumps the water back into the cold. We have an on return, because otherwise if I turned this tap on, the chances are that cold water would come backwards up here and we'd have cold water out the tap. So very simple and straightforward to do it with an electric storage water heater. For larger houses, we often specify our three-phase multi-element cylinders, which have got much quicker recovery. So exactly the same story for a larger heavy-duty electric cylinder. The difference with these is we've got large pipe connections on them, so we can get lots more water into and out of them, but the same basic layout of the ring main. If we move next to our fast recovery gas storage system, so we call this a demand rapid. It consists of a 450 litre storage tank with a Rinnai Infinity on the front. This is our absolute go-to product for large houses with ring mains, where the client is accepting of a gas solution. Lots of spa bars, lots of outlets. This will run a small motel. So for our large architecturally designed homes where they're happy to have gas, this is the solution. And again, very simple for ring mains. And again, these have large port connections. We just hot out the top, loop the ring main back into the cold at the bottom, and it's done. So it's really straightforward. The next application, of course, we have is just our Rinnai Infinity. The Rinnai Infinity is designed to heat a reasonable amount of cold water. It's not designed to have its burner going on a really low flame to just make up the little bit of heat that you've lost out of the ring main. So we can't simply run the ring main of an Infinity back to the cold inlet. You can do, and it'll work. And in a couple of years, you'll be calling us up, asking us why your Infinity is playing up and causing you difficulty. So we don't recommend bringing the ring main simply back into the cold of an Infinity. Really inefficient, really high emissions, just is not the thing to do. So what we do is we take a small electric cylinder with a 2 kilowatt element normally plugged into electricity. When a tap's turned on, cold water is heated by the Rinnai Infinity. it runs into the small cylinder and hot water comes out the tap. When there's no tap on, the water just runs around the ring main and back into the cylinder, and the electric element tops up the heat that's been lost from round the ring main. For larger houses with larger ring mains and more water heaters, we have 57 litre, nearly 60 litre cylinders with large port connections on them that we can use to do the same job. So effectively, the only time the infinity goes is when someone turns a tap on. Otherwise, the ring main's just being kept topped up with the energy from a small element in a small cylinder. Heat pump water heater. So this is the last one. We're nearly there. Heat pump water heater, we use a small cylinder for a couple of different reasons. One is that heat pump water heaters really like heating water from cold to hot. They're inefficient heating water from nearly hot to completely hot. And so if we run the ring main back into the cold inlet of a heat pump water heater, we do two things. We ask the water heater to heat lukewarm water or nearly hot water, which it's inefficient at doing. The other thing is this water heater is designed to have nice hot water at the top and normally nice cold water at the bottom. And when we run lukewarm water in the bottom, we stir up the tank and we mix up that water inside, and we'll have lukewarm water in the bottom of the tank. So then when the heat pump does turn on, it operates much less efficiently. The other thing is by feeding water and stirring up the tank, we will cause the thermostat of the heat pump water heater to turn the appliance on and off much more often. And there's quite a load on the compressor when a heat pump water heater starts. And so if we were to run the ring main straight back into the water heater, we'd have a lot more starts on the compressor, and the heat pump water heater would need lots more maintenance and it wouldn't last as long. So we recommend for our water heater, we bring the hot outlet from the heat pump water heater out into the bottom of the tank. We come out of the top of this electric tank, go around the ring main, come back into that electric tank and reheat that water. So there we are. That's everything you wanted to know about ring mains, but were afraid to ask. So I'll hand it back to Alice now.
Thank you very much for the informative presentation, Grant. Now it's Q&A time. We've also put up the contact details of our specification team at Rinnai. Please feel free to get in touch if you have more questions about the webinar or require assistance for specific projects. Also a reminder to please contact us if you're interested in morning tea presentations or a quick catch-up on product updates. Now here are some questions. So there's the first one, we actually received it prior to the webinar. So let's start with this one. Dr. Grant, how would I do ring main with a solar water heater?
Thanks, Alice. That's a good question. So there's lots of different setups of solar water heaters, but fundamentally we would normally do it the same as a heat pump water heater. We want to keep nice cold water in the bottom of our solar water heater so that the panels on the roof, if we're talking about solar thermal, can heat the nice cold water to hot. So that's solar thermal on the roof. If we've got solar PV, so we've got solar electricity being generated on the roof, we can do our ring main just exactly the same as we do for an electric storage system. So the solar PV, we do like electric storage. Solar thermal, we do like a heat pump.
All right, so the next question is, can the UV bulbs fail throughout the year without the homeowner being aware of this?
I suppose in theory, any bulb can fail. The controllers, I think, will put out an audible alarm were that to happen. We've had them in our building for many years, and that's never happened. And I can't recall that happening in I visit many buildings that have these installed, and I can't recall it happening. Perhaps one of the things is that the audible alarm is actually somewhere where someone's going to hear it. They've normally also got a switch on the controller, so you could have it flash a light or do some other tricky thing to let you know that the bulb had failed if it had. But what we do see lots of is the bulbs have never been replaced. They're 10 years old, not that they've been failed in 6 months.
Cool. So next one, can you use a warm water system for a house with a central heating system, which is reticulated radiators in every room, or does this need to be a hot water system?
Okay, so yes, you can, but just bearing in mind that the hot water going through your radiators is not potable hot water. It's completely separate from your potable hot water system, the water that's coming out your tap that you're putting in your cup to drink out of. So yes, you can have a system. You can have a warm water ring main coming from a storage tank that's also got a system in it to supply hot water around the heating system, but the heating system and the drinking water system will be completely separated. And if you want to do that, if you send the team a question, we'd be happy to send you some schematics of how to do it.
Right, how easy is it to retrofit a ring main system?
So it depends on the access that you have available, and particularly how you're going to get a pipe from your furthest outlet back to the water heater. And then having done that, where you're going to put mixing valves in order to be compliant with the building code. So you can absolutely do it. Now, if you go online and Google this, you'll find these really cunning things that are available in America and in Europe, where you go to the basin of furthest from the water heater and you put a T on the hot and cold connections to the basin furthest from the water heater, and you stick a pump with a temperature sensor in there. And then what it does is it pumps water out of the tank and it pushes the lukewarm water back up the cold side in order to make a loop, so you don't have to install a special pipe. My view is that those are absolutely not compliant with the New Zealand Building Code and that we shouldn't be using them. It's a really cunning idea, but they're not building code compliant. So you might come across those if you start Googling, but in terms of retrofitting, you need to run a pipe from your furthest outlet back to the water heater, and then you need to fit some mixing valves or fit a UV sterilizer. So it entirely depends on the construction of your house and the access that you've got. It can be really easy, or it might be nearly impossible.
We've got a lot of questions, so I'm going to just pick
Okay.
up a few, and we might have to get back to people afterwards. Grant, any comments around using a ring main and tank as an energy store alongside solar PV, overheating it with excess power?
Yeah, so that's sort of a whole another topic for another day. So if you're going to do that, you need a stainless steel tank. This is kind of slightly off topic. You need a stainless steel tank because the stainless steel tank can have really hot water in it. The enamel steel really only wants 82-degree water in it, or the rate of removal of enamel from the inside of the tank gets advanced. So you want a stainless steel tank. You want to make sure that the pipe around your house, okay, so you could do a warm water system like that, no problems. If you wanted to do a hot water ring main, you need to bear in mind that you're potentially going to have really hot water going around your house. So the pipe has to be able to take that, which is code for it really needs to be copper. You wouldn't want to do that with plastic pipe or you're going to melt it. And then you really want mixing valves on all your outlets, because you might have 90-degree water come out your kitchen sink on a sunny day, and that's just dangerous. You're allowed to have that, but it's just a bad idea. So yes, absolutely, you could implement that. It's reasonably common overseas and will become more common here, that where you see you have a sensor on your electricity supply line coming into your house, where you see the electricity running backwards back into the grid, rather than get some miserable cents per kilowatt hour rate from your electricity retailer for the electricity you're selling back to them. You switch on your electric tank and heat it hotter than it otherwise would be. So you really want a stainless steel tank, and you really want to make sure nothing's going to melt when you do it.
And Grant, you mentioned UV sterilizer. So why is a UV sterilizer needed when the water still has to circulate through the 65-degree cylinder?
Okay, so as I said, the picture that I put up isn't exactly how it's done. When the water comes back, the ring main comes back in a warm water system, some of the water goes back into the tank and some of the water continues round the ring main. So not all of the water is being disinfected by the ring main on every pass. So yeah, it's not quite like it's been drawn in the picture. Some of the water short circuits the cylinder and goes straight back into the ring main again.
Thank you. And before the last question, we've posted a survey link in chat for today's webinar, which only takes 1 minute to complete. We're very keen to know the topics that you would like to hear from Rinnai and your feedback, so we can make these webinars better for you. It's also a way of us knowing that you've attended the webinar today. So final question, Grant, what is the recommended pipe material?
So a warm water ring main is no problem with any pipe material. And equally, a hot water ring main, it depends how hot you're going to make your hot water source. So as I spoke about the previous example of trying to use your PV and make it really hot, you really need copper if you're going to make it really hot. If you need, if you're not going to have a water heater that's set really hot, then you just need a polymer that's suitable for the water temperature that you want. When you're looking up the specification of polymer piping, it gets a bit tricky. You need to, as the water pressure increases, the temperature at which you can operate it decreases. So you and your plumber need, or the plumber mostly needs to check that whatever temperature it's going to operate at, that the pipe is suitable for the pressure it's going to operate at. So really high pressure, the allowable temperature goes down. Really low pressure, the allowable temperature goes up. So you can absolutely use plastic, but it's got to be sufficient for the temperature of water that you're planning to put through it. And unfortunately, there's lots of examples in commercial building where there's a particular pipe that I won't name because I don't want to get sued, that the plumbers didn't recognise this relationship between pressure and temperature, and it's failing all over buildings. So it's something to be really careful about. You don't have to use copper, but if you're wanting to have the water really hot, then copper's often the best solution.
Right, thank you. Thank you very much, Grant, for a great presentation and the answers from Q&A. Now, our next webinar of the CPD series is on a hot topic in winter, wood burners, on the 15th of August. This will be part 1 of the wood burner series, where we talk about compliance and regulations such as clean air regulations and things to remember when specifying indoor wood burners, and most commonly asked questions. Thank you very much, everyone, for your attendance and participation today. Hopefully, you have now a better understanding on ring main systems and more options for you and your clients after today's webinar. Thank you again. See you next time. Mā te wā.